Good afternoon. The topic of my presentation is muscle oxygenation, insights for training and performance. So basically I will tell you how can we measure muscle oxygenation, so what happens regarding oxygen uptake or muscle oxygen extraction within the muscle. And I'm going to present also some examples of work that we have been doing in our lab regarding this topic. So if you can, we can see now the classical picture of exercise physiology proposed by Wasserman that shows the pathways for oxygen from the air that we breathe until it's used in the mitochondria. On the right side, you can see the use of gas analysis that allow us to determine the pulmonary oxygen uptake, so measure that amount, and it gives us a profile of the response of the whole body. And on the left side, if you want to look at what happens at a muscle level, usually we have more invasive techniques, but recently a technique non-invasive has been developed, which is called near-infrared spectroscopy, that allows us to see what happens in regards of oxygen extraction within the muscle. So how does near-infrared spectroscopy works, NIRS for short? Basically, it uses an atypical absorption of different molecules when they are binding with oxygen. Basically, we have a probe that is placed on the skin. That probe emits a light. The light passes through the tissues, and then it's received on the other end. And we can have some measures given from the different wavelengths that are received on the receptor side of the probe. So what does this mean? We can have now, just with a probe placed on the skin, a measure of that muscle, that tissue that is analyzed in what regards oxygenated hemoglobin, deoxygenated hemoglobin, tissue oxygenation, and total hemoglobin. And basically we considered, or the literature considers, HHB or deoxygenated hemoglobin as a surrogate of muscle oxygen extraction. So we can have a picture of what happens in exercising muscle in what regards to the oxygen consumption, oxygen extraction. So we know what we are talking about. Now I'm going to present some different works that have been ongoing in our lab, different types of exercises, different types of purposes in each study. I will start to present you a study that we did that compared continuous with high intensity interval training, so in running. Afterwards, I will present how this measures muscle oxygenation and muscle extraction influence or not, that was the question, a repeated sprint performance in judo athletes in upper body exercise. And last but not the least, I will present a study in a specific kind of strength training, blood flow restricted exercise that aims to increase metabolic stress. So we try to see if different kinds of different levels of pressure influence the muscle oxygenation and muscle extraction within the muscle that was working. So the first study, we compared the effects of low volume 4 weeks of training, either continuous training or high intensity interval training. So he had two groups that trained for 4 weeks. We did several measures before and after the four weeks. Namely, we measured the basic aerobic parameters, so VO2 max and the ventilatory thresholds. And we also tried to determine the oxygen uptake kinetics, so measured at the mouth, and the oxygenation kinetics measured as HHB data. We tried to see if after training our oxygen uptake, pulmonary oxygen uptake or muscle oxygen extraction was faster after the training. So we used breath-by-breath analysis combined with NIRS data. So we found that only the HIIT group improved the VO2 max, and both groups showed increases in maximal aerobic velocity. But when we look at the kinetics, neither the pulmonary oxygen uptake kinetics or the HHB kinetics improved after training, which was somewhat surprising. However, when we look at this, the cardiopulmonary and the muscle extraction data combined together, we see that the ratio between the muscle extraction and the oxygen uptake was decreased after training in the HIIT group. So this seems to see or to show that was a better matching between oxygen microvascular distribution and its use within the blood, the tissue that was analyzed. So it seems that the peripheral adaptations were higher in the HIIT group. So passing to another example of what we can what this NIRS analysis gives us, we tried to see if judo athletes with higher performance in repeated sprints, in this case we use an arm ergometer, as you can see in the picture. We tried to see if individuals or judo athletes with better performance were the ones that had pulmonary and muscle oxygenation kinetics faster than the ones that have lower performance levels. So we did basically the same measure that I told you before in the previous study. In this case we used transitions from rest to heavy intensity exercise, and obviously we did a performance analysis in a repeated sprint test, in this case also in the arm ergometer, with 4 times 15-second sprints with 45 seconds of rest, as performance to measure peak and mean power in each sprint, work in each sprint, and accumulated work within the four sprints, and also we measured the HHB data in the triceps brachii. As you can see, basically the main differences in the HHB response between trained and untrained were that the trained judo athletes had higher levels of muscle oxygen extraction, and on the right you can see that the mean power was obviously decreasing along the sprints, but the judo athletes were able to in all the sprints have higher values of oxygen extraction. In fact, when we performed a regression analysis, we found out that what predicted performance in the sprints were, by one side, the VO2 max, but also the amplitude or the maximal amplitude of the HHB response. So if you have higher levels of oxygen abstraction in the sprints, in this case in the last sprint, you have better performance in this kind of exercise. So the last study, we tried to look at a specific kind of strength training, so really different from the other 2 studies, to show what are the different applications of this variable, what can we gain from this. And we look at the blood flow restricted exercise, which is basically resistance training exercise with a cuff that applies a certain pressure and restricts blood flow to the working muscles, and specifically the venous return from those muscles. And we try to see if applying different restrictive pressures influence the response of deoxyhemoglobin and tissue oxygen saturation. So we look at the vastus lateralis for the oxygen extraction measurements, and each participant performed an exercise set with 30 repetitions, 15, 15 and 15, with 30 seconds rest, with 20% RM, which is typical for this kind of training. And each participant performed this training or this exercise protocol in 4 different conditions: without blood flow restricted so without any external constraints, with 40, 60 and 80% of the arterial occlusion pressure, so the pressure that does not allow the arterial blood to go to the muscle. We use lower levels than that. So what we found on the left, you can see the response of the HHB throughout all the exercise, and you can see that the higher the pressure, we had more muscle oxygen extraction, but without differences between 60 and 80% of AOP. Even when the subjects are resting between sets, we can see the higher levels of restrictive pressures, 60 and 80, increases oxygen extraction within the exercise, but does not allow for recovery within sets. If you are looking at to induce metabolic stress within the muscle in this kind of training, it seems that you have to use at least or more than 40%, because that's the pressure, or above that we saw metabolic or more deoxygenation, less recovery between sets. So to conclude, I hope that you now are convinced that NIRS is a valid and non-invasive method to determine muscle oxygenation and muscle oxygen extraction, and you can use in different setups, different kinds of training, different types of exercise, different kinds of types of muscles, and that this measure or this variable can give us important information for acute and chronic effects of training, and this seems to be also related to better performances and repeated sprints. And thank you very much.